Good evening and welcome you all for this lecture on realization of logic gates. So in this lecture, we are going to see how to realize logic gates. This is our main theme of this lecture. So first, before starting this, I am going to tell you what is mean by a realization. So that is very, very important. So realization. Realization means what means? Now I am teaching you digital electronics as a theory. If I want to check whether this theoretical concept can be applicable or not, that means that is called as realizable or not. Realizable means looking a concept with the help of another one. That is, we are going to realize with the help of Python. So is there any relationship between Python and digital electronics? Means directly there is no connection. But what we are going to do is whatever I am teaching here, I am going to realize that with the help of Python. So in a summary, if I want to tell as a nutshell means what I have to tell, realization means it is nothing but seeing something with the help of other thing. With the help of other. Realization means what? I am going to test or analyze or observe something in terms of other. So if I am telling in the as a simple words means you don't understand, I will take one example called NOT gate. So here you already know that A and A bar, these are the two outputs. If I give A means NOT gate output will be A bar. That means 0 means it will produce 1. 1 means it will produce 0. This you all know already, right? So can I realize this NOT gate with the help of another gate? Means yes, you can realize with the help of NAND gate. Why means in the logic gate family, there are 7 gates available. Already in the previous lectures we discussed AND gate, OR gate, NOT gate, NAND gate, NOR gate, XOR gate and XNOR gate. Like that 7 gates we already analyzed how it is working, everything. But here these two fellows, NAND and NOR gate, these two are called as universal gates. Why we are calling it as universal gates means with the help of these two gates we can realize any logic gate. You can physically realize means what? The same output will come using by modifying this NAND or NOR suitably, you can be able to get the same output what this NOT gate is producing. Actually, NAND gate is a totally separate gate, but this NOT gate output can be realizable using this either NAND gate or NOR gate. That is our main concept. That is called realization. So what I am doing is I am putting one NAND gate here, but you can see there is only one terminal available. So what I am doing, I am just shorting the two terminals and I am giving common input as A. So this terminal will also become A and this terminal will also become A. So what will be the output? A dot A the whole bar. So usually what is the output of NAND gate? Usually output of NAND gate will be, okay. Here I will. Usually output of NAND gate will be what? If A and B are given, then what will be the output? A dot B the whole bar. Similarly, here both inputs are A only, so I am giving A dot A bar. So what will be the output? A bar. Okay, so this is how we are going. This is how we are just thinking how to realize some basic gates by using universal gates. In the same manner, I can use NOR gate also. This is called as NOR gate function. So both terminals are shorted. So I will get A plus A the whole bar, which is nothing but A bar. So both are output of the NOT gate. So NOT gate can be realizable by using either NAND gate or NOT gate. So not only NOT gate, any function can be realizable. That is the speciality of universal gates. So that realization we are going to see brief in this lecture. That is what the main concept is. So I think this is understandable. So base thing I will keep into picture and I will realize something that will be benefit for you. Okay. So next we are going to see what is mean by a NOR logic. NAND NOR, what is that? What is mean by realization? Everything we will see in a short, in a brief manner. So, yeah, right. So what I am doing is I am going to realize AND gate as a NAND gate. Can you just work out along with me? This is AND gate. So A, B, output will be what? A dot B. If I want to realize that by using NAND gate, then what I have to do? I need to do like this. That is, this AND gate, I need to add one bubble. For this, I need to add one compensation NOT gate. So these two things will get cancelled. So AND gate will be as it is. So for adding this bubble, I am adding one NOT gate as a compensation. So that two gate get cancelled each other. So this is called a balancing. Okay. So if I give AB means what output you will get from NAND gate, A dot B the whole bar. So after pausing this circuit, what you will get? A dot B the whole bar, another bar will come. This bubble will introduce one bar. This NOT gate will introduce another bar. So what these two bars get cancelled. So what will be the output? A dot B. A dot B is nothing but what? Output of AND gate. So now NAND gate is working as a AND gate. Okay. So for conversion, what you will do generally means this NAND gate during realization, everything should be in the form of NAND gate only. So you should not get another NOT gate. So what I am doing, NOT gate can be drawn as NAND gate by shorted input. So if I give means what you will get? A B, A dot B bar. If I give this means automatically you will get A dot B double bar. So what answer you will get? A dot. This is this is how you are realizing this function, right? So now I think this is understandable. Fine. So this erasing portion, I have to erase. So right now, what I am doing is I am going to teach you now what is mean how you are going to do this realization part. For this, before I am going to tell you about De Morgan's theorem. Why I am teaching this means this is very important when we are realizing this exercise using Python. So what is mean by De Morgan's theorem? De Morgan's theorem has two rules. One is A dot B the whole bar is equal to A bar plus B bar. And then second rule is nothing but A plus B the whole bar is equal to A bar dot B bar. Like that, two rules are available. These two rules, how we can prove? That is the main thing. So how to prove these two rules, right? So first I am taking A and then I am taking B. So I am writing the probability 0, 0, 0, 1, 1, 0, 1, 1. And then I am writing A dot B. A dot B means what? Dot operation. So 0, 0, 0, 1. Next, what we are doing, a dot b whole bar. Whole bar means what is the meaning? Opposite of this 1 1 1 0, right? And then a bar plus b bar I have to do. First I will do a bar and then b bar, and then I have to add these two things, a bar plus b bar. So a bar is nothing but what? 1 1 0 0. Look at this a 0 0 1 1. Opposite is 1 1 0 0. B bar is nothing but 0 1 0 1. That is 1 0 1 0. 1 0 1 0. A bar plus B bar means what you will get? This is 1. This is 1. This is 1. This is 0. Now, if you monitor these two things, these two are automatically what? Equal. So these two functions are equal. So now what is our work is, I am going to write a coding in Python, that is the realizing using Python. So I am going to write coding part. For writing coding part, some of the things are very important. What are all the things we will see now? So this part I am taking once again a, okay. So a dot b, the whole bar is equal to a bar plus b bar. So how to write coding for this? That is important. So how to write coding means what we have to do. This is nothing but NAND gate out. This is nothing but NOT gate. This is also not. This total combination is due to a OR gate. So these are the gates involved. So first we need to write definition for each and every gate. First I am going to write definition for NAND gate. So usual format is definition, the name, and then variables. And then you have to write return. What this definition will return. That thing you have to write. This is the common format. So first I am going to write definition of NAND gate. Why I am putting NAND underscore gate means NAND is a built-in function used in Python. In order to avoid the confusion, I am just writing NAND underscore gate. You can also use definition of A, B, C, X, Y, Z, whatever you want, you can use. But for my understanding, this is NAND gate. So I am putting NAND underscore gate means this is a normal text. It will not be a user-defined function, built-in function. So Python will not get confused. For that purpose, what I am doing, NAND underscore gate I am putting, and I am giving two variables, these two variables a comma b. And then it will return the value. What a value it will return? That is integer of, it is going to return either 0 or 1. So not of a and b. Not of a and b is nothing but what? NAND. So whenever you are calling this key value, this is called key value. NAND gate, wherever you are calling, it will return NAND gate operation. It will do NAND gate. This probability will be written everywhere in the program. So next, what is our role? We have to write definition for NOT gate. So definition of NOT underscore a of a. Only one variable. So it will return one integer, that is nothing but what? Not of a. Not of a. Similarly, I am going to write definition of another NOT gate, that is nothing but not of b. That is b. So it will return integer of not of b. This is function. These are all inbuilt functions. Here I am using is key values. Okay, we are using is key values. Next, this is important. I am going to write definition for OR gate, OR underscore a gate of, what I am going to do. I am going to use two variables, a comma b. So what it will return? It will return integer of not 1 or not 2. Right? Not 1 or not 2. Otherwise, you can write like this, integer of or of not 1 comma, whatever you want. So this will be my what we call it as De Morgan's theorem, for how to write the De Morgan's theorem. Okay, here also I am doing the same. Not of A and B. Here or of not 1, comma, not 2. This is the thing. So let us go into Google Colab and check whether these functions, whatever I am realizing here, this truth table is coming or not, how to build the program, that I will tell you. Let us pause into this Google Colab. Same thing I have written, you can check here. Definition, I am writing NAND underscore gate A comma B. Return integer of not of A and B. This is for NAND gate. NOT gate is nothing but not of A. NOT gate is nothing but another NOT gate, and OR gate is nothing but int A or B. So two forms are available. You can use anything. So De Morgan's theorem is nothing but what? OR gate of NOT gate of A comma NOT gate of B. Here I have given this. NOT gate of A comma NOT gate of B. This is total De Morgan's theorem principle. OR gate will be integer of A or B, like that. It's similar to that of NAND gate. You can form one definition. Now I am going to print this De Morgan's theorem, that is input A, input B, y of A dot B whole bar is equal to A bar plus B bar. We have seen now same thing. A bar plus B bar, same thing I have written in the form of snippets like this, and then print. And then for in last session we have discussed A probability, B probability. Output 1 will be De Morgan's of A comma B. Output 2 will be NAND gate of A comma B. That is the speciality. So De Morgan's output is nothing but what? OR gate of NOT gate A comma NOT gate B. OR gate of NOT gate A comma NOT gate B. Like that only you have to write. Here how you will write? AND gate of NOT gate A comma NOT gate B. This is this part. That is, I am declaring it as De Morgan's. But what is the right hand side? Right hand side is nothing but simple NAND gate. Here simple NOR gate. So NAND gate, I am calling it as De Morgan's of A comma B is this total function, and NAND gate is nothing but this A comma B function. Then what is the use of this OR gate? Means OR gate, I don't have any, as of now I don't have any calling function here. I am using only OR gate of this OR gate. It will come here. This OR gate, if I click here, means it will show where is that. So we are going to perform OR gate of NOT gate A comma NOT gate B. For that purpose I am calling this OR gate. Okay. So AND gate I am not defined. While developing the next program, I will show you how to write the program for AND gate. So after doing this, what happened? I am printing the function. First I am writing A and then pipe symbol, B, pipe symbol, output 1, output 2. Output 1 is nothing but what? Total De Morgan's value. That is total OR gate of A bar plus B bar. And output 2 is nothing but what? Simple NAND gate. If I prove these two are equal, means my problem is solved. So if I run this, means I will get the output. You can see whatever I have written there, you will get 0, 0, 0, 1, 1, 0, 1, 1. A dot B whole bar is nothing but what? 1, 1, 1, 0 that you are getting here. And A bar plus B bar is also 1, 1, 1, 0. Fine. So like this, you have to write the coding. Now, what I am going to do now is, second part we are having A plus B whole bar is equal to A bar plus B bar. How can we develop? Is it easy or difficult? It is very easy. First, what you have to write? I need to write definition for a NOR gate. Earlier we have written NAND gate. Now you have to write definition for NOR gate. Definition of NOR underscore gate of A comma, then what it will return here, I have to put colon. This is the definition statement. After that, what I have to write? Return automatically Gemini will generate. If you are having assistant, AI assist means you don't need to worry. Directly it will give the codings. So here I am getting the code return int of not of A or B. This is my requirement. Automatically I am getting. So first you realize whether it is correct or not. Sometimes Gemini will tell you wrong suggestions also. You have to use or not use, that you have to decide. That there the human intelligence will work. So first, what is the thing over? NOR gate is over as per this. Then not of A and not of B is already defined in the previous statement. First time you are writing means you have to define. Next time onwards, this not gate of B can be called again and again. So no need to write this. So next what I am going to write, I am going to write definition for AND gate. That is very important. So definition of AND, already it is coming means you can take. Okay, it will come based on the previous suggestion, it will come. So tab definition AND gate of A comma B, return integer of A and B. So automatically De Morgan's also created return AND gate of not gate of A comma not gate of B. It is serving or not? Yes. AND gate of not gate of A comma not gate of B. I didn't do anything. Everything is auto generated. Now after this, what I am going to do? I am going to print this statement. What statement I am going to print? Same thing. So print of all these things I am copying. Okay. Output one, I will give you a space here. After that I will do some the previous statement. I am just copying and pasting. First time users, you have write print De Morgan's theorem. Print input A pipe symbol, input B, A plus B the whole bar. Okay, that you can simply write A plus B the whole bar is equal to A bar dot B bar. Fine. And then everything over. So here what I am going to do, that is important. Output 1 is equal to De Morgan's of A comma B. Output 2 is equal to NOR gate of A comma B. Finish, right? I think everything over. Everything over. So if I run means what you will get? I will get the output like this. So 0 0 0 1 1 0 1 1 A plus B the whole bar is equal to what happened? A plus B. You can physically verify. 0 plus 0 is 0, opposite is 1. 0 plus 1 is 1, opposite is 0. 1 plus 0 is 0, 1, opposite is 0. 1 plus 1 is 1, opposite is 0. A bar dot B bar means what happened? This is 1 1 0 0. 1 1 0 0 means what happened here? Here also 1 0 1 0. So automatically you will get this become 0 0. So automatically everything will become 0. So 1 1 0 0 0 0. So De Morgan's theorem is proved. Within a short span, we are proving the De Morgan's theorem. I think it is understandable how to develop a coding. Okay, this coding exercise is very, very important for doing the realization part. Now what I am going to do is we are going to see realization of simple logic gate. That is our main aim. Okay, so I think the simple coding is understandable to you. So realization of sim logic function using universal gates. So what is this? Let us see what is the main idea of this. So what I am doing is y is equal to, I am taking a function ab plus bc. AB plus bc. So don't think this is alphabet. These are functions. This is a AND function. This is also another AND function. Total combination is a OR function. So if I want to draw a diagram, I can draw like this. One is A, another one is B. I am putting one AND gate. Okay. Next, another one is B, another one is C. I am putting another AND gate, and then I am just putting one OR gate. Okay, so this become Y. So you can see here, this is AB, this is BC, and this is AB plus BC. Fine. This is not, this is very simple. How many gates are involved? You can check. One AND gate, two AND gates. So 1 second, and another one is 3. So how many gates totally available? 3 gates. But when I am choosing one IC for this, there is one IC name IC7408. Okay, that I will show you in the Tinkercad so that you can able to understand what is the thing happen. So Tinkercad, how to open Tinkercad also you understand. Type Tinkercad in the Google and then type enter. You can choose one account, whatever you want. And then here you will get some plus symbol. This is a very interesting tool. So those who are in mechanical or any other things, you can able to do designs also here. Many designs are available. You can do this. And if first time users, you have to click this create button and you have to select circuits. So circuits means you will get the blank page like this. Someone will create, you can tinker this, or you can create your own page. Some jumbled names will come. Here you can change whatever you want. This is, I think, realization of logic gate means I can type realization of logic gates like that. I can type. So that become yours. Right now, what I am doing is I am going to type 7408. That is nothing but what it is written here, quad AND gate. It's nothing but quad AND gate. So why I am taking AND gate? Here I am having two AND gates. Two AND gate means here what is the meaning? Quad AND gate is coming. Why I am choosing this means you can realize what is the actual thing. So if I click this means you can able to see something called, this is how we can realize. So 7408, this coding part, that is none. Okay, so the logic behind this you can see, but how to see, let us check here. Toggle nodes and then this one. I think we can see with the help of one quad NAND gate. Okay, 4 logic gates that each have a high output when all of their inputs are high. You will get a complete description of this. You will get a complete description of this. Like that you can take. But for using these two AND gates, 1 and 2, I don't want two different ICs. What is the meaning? Yeah, I forgot and I'm sorry. Here you can see here. This is the real glimpse of Tinkercad. You can open and check what is inside the IC. What is inside the IC? Just I will zoom. You can download PDF also. This if you want. You can see here AND gate 1. How many AND gates are available inside this IC? 4 AND gates. As per for realizing this, how many AND gates actually we require? 2 AND gates. So what I can do, I can use these 2 AND gates and 2 AND gates will be free. These 2 AND gates. So this IC is required. There is no change, right? Next, what I want to do, I want one OR gate. So I am typing the name 7402. 7402 is NOR gate. So what is the IC number 7432? 7432 is nothing but what? Quad OR gate. So I am taking this out. Okay, and now I am clicking this symbol. If I click this symbol means two things you will get. One is AND gate and another one is, first one is what? OR gate. You can check here OR gate. How many OR gates are available? Quad means 4. So 4 OR gates are available. This set of either anything you can use this one. So for realizing the function, for example, I am fixing this and this like this. So I will put this before this and I will check out so that you can able to understand. If there any change, it is hierarchically it is fixed. So no need to worry about this. So I want these two AND gate and one OR gate should be connected. Should be connected like this only. two AND gate and one OR gate, right? So after realization, what magic is our main game. So realization is possible by using two. One is you can realize completely by using NAND, or since these two are called as universal gates. So first we will see what is mean by NAND realization and what steps you have to follow that you have to for NAND realization. First I will tell the steps and then you can do realization. If I see one AND gate, then I have to convert that into NAND gate first. How to convert means in the output you have to add one bubble. For compensation you have to add one NOT gate. If I see a OR gate here, then what I have to do? I have to in the input end, I need to add one inverter. Compensation, you need to add one bubble. Another inverter, add one bubble. So this will become a like this. And after this, what you have to do? I need to convert all these things into a NAND gate. Since NOT gate is nothing but a shorted NAND. Okay. And here also this is nothing but a shorted NAND. Following this will be this bubbled OR gate will be another NAND gate. So always remember NOT gate is a shorted NAND. This NOT gate is also a shorted NAND. Bubbled OR gate will be a NAND gate. You can replace this as a NAND gate. This is for NAND realization. And one more thing, if two inverters are coming in a same line, you can cancel the two things. That possibility is available. So for NOR realization, what you have to follow means if you are seeing one AND gate, then what you have to do? I need to add inverter in its input terminals. NOR gate means AND gate means input side, OR gate means output side. NAND gate means what you are doing? AND gate output side, OR gate input side. Like that you have to do. So NOR gate means AND gate input side. So you have to put bubble and put one AND gate as it is. Now this become what? Shorted NOR gate. Shorted NOR gate. Bubbled AND gate will become one NOR gate. That's it. And then what I am doing? If you are seeing OR gate means for NOR realization, directly take the OR gate, put one bubble, one invert. That's it. This is called as how to conversion step, how to convert this gate into equivalent. Now what I am going to do is I am going to convert this into NAND logic, which function earlier I draw one circuit AB, BC, and then AB plus BC. Already I have explained to you AB, BC is done by means of one IC, and this OR gate will be realized using another IC, that is YC. AB plus BC. Fine. Next, what I am doing, I am going for conversion process. This is what logic you need to understand. This is NAND logic. NAND logic means what you will do. First, I am taking one AND gate, NAND logic. So in the AND gate output side, I am adding one bubble and one inverter for compensation. And similarly for this PC also, I am taking one NAND gate. AND gate is converted into NAND gate. For compensation, I am adding one inverter. Right. And then I am looking one OR gate. Listen here. This bubble compensation, this bubble compensation. Now I am working for OR gate. OR gate means what you will do? In the input, one more NOT gate will come. For compensation, I will add one bubble. Similarly, one inverter will one compensation bubble. So I am just putting this OR gate as it is, right? So now what rule we have told earlier? If two inverters are lying on the same line, I can cancel these two things. And if I redraw this circuit, what circuit I will get? One NAND gate followed by another NAND gate, and this bubbled OR gate can be converted into a NAND gate. Now you can imagine, sir, okay, A, B and B, C. Now you can work out on this function. What is the output of this NAND gate? A dot B whole bar. What is the output of this NAND gate? B dot C whole bar. If these two functions come outside, means what you will get? A dot B bar dot B dot C bar BC bar whole bar. As per De Morgan's theorem, A dot B can be replaced by what? AB double bar plus BC double bar, right? A plus B the whole bar. So A bar plus B bar. So this is AB bar is treated as A, BC bar is treated as B. So A bar is already there. So double bar plus BC double bar. Bar and bar get cancelled. So output ultimately AB plus BC. This is what. So same output I am only with the help of NAND gate only. You cannot see even other gates like NOT or and you cannot see. Only by using NAND gate I am getting the IC. I am getting the same function. So now what I am doing is I am going to take you, this is the thing, 7400. 7400 is nothing but what? NAND gate. So I am taking this. So if I click this means you can see here. Okay. Wherever is available, you can check. Okay. So this is somewhat mess up. Okay. I will keep this and I will zoom here. You can see here, this is the NAND gate formation. So actually, how many NAND gate required here? 1, 2, 3. 3 are NAND gate only. So if I choose this IC, 3 NAND gates are available within the single IC only. So how many IC requirement I want? Only one IC is sufficient. So for doing this experiment, so using normal logic gate, I need 2 ICs. One is for analyzing AND, another one is for analyzing OR. After realization using NAND logic, the same output I am getting, but requirement of IC is only one. That is nothing but what? NAND IC. So what is the advantage? If I build the IC using this in a breadboard or in a physical, I need 2 ICs to be placed, but the same operation can be realized using single IC. So what is the advantage? Space conservation. Space conservation. Nowadays, you all understand that all components are now in a very sleek manner. And if space is reduced, means component space will be, the bulky size of the component will be reduced. And the number of component utilization is actually reduced. If number of component is getting reduced means automatically power consumption will be reduced. Power consumption reduced means for a particular system efficiency will automatically increase. So these are the advantages of realizing any circuit using either NAND gate or NOR gate. But that is not essential. If you feel that number of components are reduced and number of ICs are reduced, so based on the situation and application, you can go for realization function. But in some category, realization become very complex. So at that time, you are going voluntarily for realizing something means that is meaningless. You are doing waste work. So you have to first compare and do a groundwork whether to implement just by using logic gate or by using universal gate. That is up to the application and designers. So if it really cost reduction is a main criteria here. If cost is very much reduced means you can go ahead with realization. Otherwise, we can use simple logic circuit as it is. So now what I am going to do is, say you are getting same thing using either NAND logic or using simple logic gates. Now in the Python code, I am going to explain you how to write program for logic gate and how to write program for NAND logic. I think you already know how to build a program. What I have to do? I need to write the definition. First, I need to write definition for AND gate using AB, AND gate using BC, OR gate using combination. Keep it aside. And then we are going to write NAND gate concept for all these things. Okay, let us check the coding here and then I will check come once again. Or what are all the things? First, I am going to write side by side. We can see. First, I am going to write definition for AND gate. So first, I am going to write definition for AND gate, but I am going to write in the form of NAND gate. So what I am going to do? NAND gate of A comma B. So that is nothing but not of A and B. Then NOR gate if you want. This is the common thing. Either NAND logic or NOR logic you are using. First, I am writing a ready-made dictionary. So this program is common for both NAND gate realization and NOR gate realization. So for NAND gate realization, I need NAND gate support. So I am writing definition for NAND gate. NAND gate of A comma B is equal to return not of A and B. NOR gate is nothing but return integer of not of A or B. And then NOT gate using NAND gate. So NOT gate using NAND gate. Previous example you realize how I return the NOT gate of A. That is nothing but return NAND gate of A comma A. There I have written not. Here I am just writing return NAND gate of A comma A. NOT gate NOR of A is nothing but NOR gate of A comma A. Everything I am realizing. So NOT gate as NAND gate, NOT gate as NOR gate, AND gate as NAND gate. So what I am doing? NAND 1 is equal to NAND gate of A comma B and return NOT gate of NAND. That is nothing but NAND 1. Here I am writing it in a separate AND gate of NAND. Similarly, AND gate of NOR A comma B. So AND gate, NAND gate means direct. I am telling output side. So what I am doing? NOT gate of NAND, return NOT gate of NAND, NAND 1. So what I am doing is here you will get confused. So NAND 1 is nothing but what? NAND gate of A comma B. What it will return? NOT gate of NAND, that is NAND 1. So did you understand what is the meaning of this? So NAND gate of A comma B means you will get one NAND gate. Here you can see here what I am doing. You can check here. Earlier I have do this. This is NAND gate, and after that what is coming? NOT gate. So this is directly I am writing here. You can write directly. So where we are AND gate. First I am writing for NAND gate. This function. Sorry, this one. First I am writing for this function, that is NAND gate, followed by what I am doing? I am combining these two things, NOT gate and NAND gate. This is what I am doing here. You can check here. So first I am writing NAND gate of A comma B, that is stored in NAND 1, and then I am combining NOT gate and NAND gate. Fine. This is for NAND logic, AND and NAND. AND and NOR means AND gate using NOR gate means what I have to do? I have to work in the input side. Input side means what I have to do? I need to work in the add the things in the input end. So like this, two NOT gate followed by one NOR gate. Both I have to combine. So two NOT gates I have to write, one NOR gate I have to write, and then I have to combine. How we are doing? Let us check. Two NOT gates I am writing, one NOR gate I am combining. Finish. Fine. Then OR gate using NAND gate. OR gate using NAND gate means same thing you have to follow. Two NOT gates and then NAND gate I am combining. And then OR gate means what I got to do? Directly OR gate using NOR gate means directly I can combine NOR gate followed by NOT gate. I will combine these things. So first, if you write all this definition means realization is not a big task. Very easily you can realize anything. Okay. So what I am doing, first I am writing normal logic gate. First thing normally we are writing now, that thing I am writing. Y is equal to AB plus BC. So these two and this. So I am writing all the things. So this is AND gate, this is AND gate, this is OR gate. So directly I am writing the function like this. You can see AND gate NAND of A comma B, AND gate NAND of B comma C, and OR gate NAND of A B comma B C. Very good, right? Everything. Then realization of Y of AB plus BC using NAND gates. Directly I have written the command. No need of anything. AB is realized as NAND, BC is realized as NAND, and this entire function is realized as NAND. Everything I have written. So after this, same thing, A in 0, 1, B in 0, 1. Here we are having three inputs, A, B, C, right? So C in 0, 1. And what I am doing is, here I am calling the function AB plus BC of NAND. And then I am just printing the values. So if I print the value means what I am getting, I will get like this. So output is Y. And this is also output is Y is equal to AB plus BC using NAND gates, using NOR gate. This is the output. So if I want to use normal output means you can check by yourself. What is the one more step I need to add, right? One more step I need to add, that is output, direct output, AB plus BC. Instead of using NAND realization, I want to use normal function. I want to verify means you can verify directly. So but usually what we will do, NAND gate implementation, if I combine means I have to rewrite the program normal. So normal logic gate we need to write. That program you will get directly. So instead of here, I will give you as a exercise that one. So what we can do here, this pipe symbol you can introduce, and then you can write another output, that is output of output, and then this while writing you have to be careful, right? So output, this is direct. I will give like this, output direct. Okay, so I think it will be working. So and then you have to close this double quotes, close this double quotes. This is how you have to write. And then if I want to extend this means I have to put one pipe symbol, and I need to write all these things. And here I need to write one more thing, that is called output direct. So what I am doing is I am typing here one more pipe symbol, and I can write one function by name output 2, that is output direct, output 2. So here what I have to do is I need to write the definition for output 2. That is my thing. So output is nothing but what, where is the output will, where the output is recognized actually here. So this is output direct. So here they are implementing the function. So I will show you now. Output is equal to Y of A plus B NAND gate they are calling. So now I have to write out what is output 2. Automatically it will come. AND gate of NAND of A comma B. Just a AND gate function. AND gate NAND already we are having. AND gate NAND of A comma. AND gate NAND of A comma B is written where? AND gate NAND of A comma B is NAND gate followed by a NOT gate. So both things are same, I think. So if I want to write a separate definition means you can write. So this is NAND realization. So if I want to write separate definition, then you have to write like this. How to write means here instead of this, output 2 will be direct. So what I am doing here, I am going to write the definition. I am going to write the definition of direct function. See here, this is direct. Direct means what I can do? I can do basic or I can do y underscore direct. Like that I can give you a name. Y underscore direct of okay, a comma b comma c. Right? And after that what? Y is equal to a and b or c. Fine. Return y. Right. That is not coming. Return a and b or b and c. This is also right. Fine. Return integer of, right? So integer of, this is the suggestion, but we need to rework. That is the main. Return integer of a and b or b and c. This is the function. You can able to understand what is I am telling. A and b or b and c. Right? A and b or a b b c plus you have to do a and b or b and c. Like that you have to follow. I think this is clear. How I am writing, you can, this is y direct. So output 2 is equal to what I have to do? I need to type y underscore direct of a comma b. This is the power of Gemini. So if I write something, it will, wherever y direct is coming, it will directly take the account and it will do. So that is output 2. This output 2 is referred here and you will get the output. So just I will run this code. Oh, some errors are coming. We will check what is the error also. I need to tell now. So forget a comma. I am forgetting one comma. What is the comma? Let us check. Okay. So where is that? Here, otherwise, if instead of wasting the time, you can type fix error. Fix error means what it will do? It will fix the error. So where is the error? It will fix. You can take NOR gate, NAND gate, everything. It will be fixing everything. NAND gate, no, not required these things. So it is fixing. Where it is fixing, you can see print f colon of output 2. Like that, it is fixing. This is fixing, right? So you can see here what it is doing actually. So this is De Morgan's theorem. So if I fix means this thing will be doubled actually. So better you can understand where is the error. This error is fixed. So only one thing I will do. NOR gate I not required. This one is fixed. This one is fixed. So f of some case I may there is one space, that space is removed, right? So I can implement that. Copy changed line, right, and then I can subtract this, copy changed line, and then I can slowly, I have to give accept or reject. So better I can reject this. I know what is the error, so I am rejecting this. But if you keep accept means it will work out, no problem. Okay, so here it is showing output 2 like that. So here is the error. So output. So why it is calling means here output to no space. Here I have given a space. That's why it is giving error. Now if I run this code means, yeah, you will get the output. You can see here output y is NAND gate realization and output direct is directly I am calling the code. Both are giving the same answers. This is how you can realize a NAND gate using NOR gate by using simple logic. I think it is understandable. I convert this and I have writing codings also. First I have written coding completely for NAND gate and then I have write for basic gates also, so that you can able to get the same output. So output 1 is nothing but here. 1 minute. So here I have written output and output 2. Output is nothing but NAND gate conversion, complete NAND gate. Here I have written this. AB as NAND, BC as NAND, or as NAND. But in the output 2, what I have did, I have write a separate definition, direct. that is A and B or B and C. No NAND gate is involved. But what output I am getting, that is the matter. Here also same output, here also same output. So this basic gate output is realized as a NAND gate output. This is called as NAND gate realization. Similarly, you can work for NOR gate also. So 0, 0, 1, 0, 0, 1. If I work direct means you will get the same output. Like that, we can able to realize any simple circuit using either NAND or NOR, and you can write the coding for this, and you can verify whether we are getting the correct answers or not. This coding is done for what diagram I have drawn in the backend. So that for that only I have written the code. Similarly, you can design your circuit and you can verify whether the answers are coming or not by means of writing a simple code using Python. Using this Gemini, automatically codes will be generated, but you have to verify and justify whether that code we want or not. That is based on human intelligence. That is where now designers are required. We don't want any coders, we want realizers. That means whatever ChatGPT or any other bot is telling, that code is really working or not, we need to understand. This is the power of this is what the actual requirement is. Okay. With that, I will complete the session. I will see you in the next lecture.